we will do a quick round of introductions in the beginning, and then we will go on with our presentation. So my name is Arman, one of the co-founders of Lambda Science, working with an amazing group of teams to deliver StepWin to you in multiple cities now in British Columbia. And today we are going to talk about some of the key topics and trends that we have seen. So I'm really excited to get that started. Before that, I'm going to pass it on to Kayla for a quick introduction. Kayla, you have the microphone.
Thanks, Armin. Hi, everyone. My name is Kayla, and I'm responsible for the business development and outreach of Lambda Science. Today, I'm going to be monitoring the chat, collecting your questions, and I will be facilitating the questions at the end of the presentation.
And Sahan, can you go next?
Hi, guys. I'm Sahan. I'm the technical lead at Lambda Science, and I'll be demoing our website and product at the end after Arman's presentation.
Perfect. Thanks so much. Okay. So the first thing, and we are really excited to talk about this, is that from today, StepWin is available in the city of Kamloops. So we are working with multiple cities, as you may have seen in our communications. And the city of Kamloops is the newest addition to that. Really excited to serve the building community there. So the builders in the city of Kamloops will have free access to a StepWin if they go to the StepWin website. And stay tuned for Sahan's presentation about the access and other details. Right now we are working on some of the projects in multiple cities very closely, and then we will start to expand the StepWin usage within the cities more as well. Beyond that, I would like to make a very quick summary of our previous webinar, where we talked about some of the introductory topics when it comes to StepWin. So last webinar in March, we first talked about approaching energy efficiency in a building. So when you talk with a builder about making their building more energy efficient, the first thing they may think of doing is working on the roof. So for example, they may say that, hey, we have learned that the heat goes up because of hot air buoyancy. So we will not spare no costs on the roof. We will make a very good system that's also performing really well. But in the meantime, it is costly. They may skip doing more things around the house and think that should be enough without working on the windows or the mechanical system. Now, if you actually give this to energy simulation software, which is the technology right now needed to ensure energy efficiency compliance in a growing number of regions, including the British Columbia with the BCS step code, you will learn that this house is actually going to perform really poorly, but it's going to cost a lot. And if that doesn't sound intuitive, the example we like to provide always is, imagine that you go skiing on a very cold winter day, but you go in shorts. You're uncomfortable, you put on a jacket. You're uncomfortable, you still put on another jacket. And that does not really create more comfort for you. That's because you're not addressing the place where the heat is escaping. And that's also the failure with this sort of design, that the roof is being over-insulated while the heat is escaping from other areas of the building, and the mechanical system is inefficient, so the amount of energy that goes into it to compensate for the lost heat is a lot. Now, if you take this design and give it to a StepWin, the first thing you will notice is that we will try to balance different insulation pieces. So we will find where we can save some of the costing from the project, and then find the other options that are they may marginally be more expensive in their own class inside the building, but overall they give you a more performant design and a more holistic performance. Think about this example as again, like a skiing, but in a tracksuit, in sort of a skiing onesie that has a very thin layer of insulation, but continuous and harmonic all around the body. So you keep the heat in from all places, and this is why this building performs better. We also, in the last webinar, we also talked about the amount of detail needed for a starting energy modeling process in a project. I think it's very important to keep in mind that you don't need to jump ahead a lot inside the construction process to actually have good energy modeling happening. The level of detail that you need in a project is essentially what we are showing you. General dimensions of one floor plan, where you want to put the windows, for example, the green lines in this drawing here, and maybe if you are unsure whether you want to put a window somewhere or not, what are the directions and what sort of foundation you are thinking about. This is more than enough to start the energy modeling process. And going early in the energy modeling process and energy compliance process is never a mistake, because we have seen this 80-20 scenario happening in different projects, that the first 20% of the decisions you are making in a project will take you 80% of the way. And you want to make those decisions early on and create a solid foundation for the rest of the project to actually have high performance designs based on the choices you do. And failing to do that will actually limit all of the things that you can do to get your design to the next level. And that may create more costs and hurdles along the way. So again, from the previous webinar, our key takeaways were identifying the energy efficiency drivers, including the building envelope, or the terminology of basically talking about properties and airtightness of the shell of the building, different pieces such as walls, windows, roofs, and etc. And also the mechanical system, the heating, ventilation, hot water providing those active elements. So think of these two as the active and passive elements inside the house, and they need to interplay and play with each other in order to make a overall good design. Another thing we talked about in the previous webinar was a compliant design versus the best compliant design. I think this is important to keep in mind that there was this BC Step Code Metrics study done, which looked at a few options for different parts of the building. For example, for ventilation, 5 options; for windows, 7 options; for roof, 6 options. And multiplying all of this together gives you an enormous number of possible cases, which you cannot really switch between without considering each of them one by one. We have this very important restriction when it comes to a project by the limitation we have of finding what is the best combination. And that may create a significant difference in the ease of reaching that energy efficiency level that the project can reach on the same budget. So we talked about these issues. Now we are going to talk about solutions in this webinar, opportunities, how this transition in the performance-based construction is going to hopefully help us not only provide better products to our customer, but also use this opportunity to deliver the next generation of the construction. We're going to talk about 4 missing pieces in the design process that used to be there, and now they have become a necessity and they cannot be ignored anymore. We're also going to talk about energy efficiency and its relation with the rest of the building project. And we're going to talk about, as I mentioned, the success pieces for the stakeholders. Last but not least, my colleague Sahand is going to give you a StepWin introduction and talk about how all of these pieces tie together with the use of a StepWin. So let's talk about this webinar through a story. I want to tell a story of a builder. Hypothetically, let's just call him Sahand. He just bought a lot 70, and he wants to build a dream house on top of it. So he goes around, he finds his architect, he finds the rest of the crew for his construction team, and they team up to create a project. They go to their city. Well, they don't go, hopefully, because of COVID-19. They check online, and they realize that The city is requiring them a step 3 house to be built in this lot, and now they want to take on their performance-based project forward and find the best design. Now, first we are going to talk about what would have been the previous system that they were working based on. So the prescriptive requirements, the way we are used to, and it has been the status quo for a very long time. So with the prescriptive requirement, they first look at they come up with their drawings. They look at different features of the house. They think about aesthetics, what sort of combinations of material, the finishings will go better with each other, what features may sell better. The conversations that really come down to the market of a house. And once they have finished all of these considerations, they will look at the timelines, the budget, the landscaping, all of those pieces. And last but not least, it's time to actually think about the energy code. Of course, they have an idea about what sort of wall would pass energy efficiency, what sort of framing depth they would need. But doing the major work of energy efficiency is left for the later stages than we are doing right now. So the first problem, the first key missing piece you see in this project is that energy usage has always been, not always, but has mostly been an afterthought. Then when they go to look at the energy efficiency, the architect, the energy advisor from the construction team, they go to the energy efficiency based on the climate zone. They will find perhaps this illustrated building guide, which tells them what level of R value or insulative efficiency they would need for different parts of the building. And referring to this, they can make sure that they are putting the right installations in the right places. But the thing is that this separation of these systems in the house may not really give you an overall proper capacity in the construction that you are doing. It's really case by case basis that the overall performance shows itself. Let me give you an example. Here we have a wall, this white section, think of it as being a wall, which is passing 25 watts per square meter of heat. And you have a window that is passing through 8 watts per square meter. The window is relatively very small, but if you look at the whole system, if you look at the overall system performance, you will see that this total system is passing through 1 watt per square meter. And that's 4 times the amount of heat that the wall on its own is passing through. But if I make the window even larger, that heat transfer is going to be much, much larger, almost 10 times the wall insulation level. If this doesn't sound intuitive, think about the building envelope or those walls and windows as a bucket, and the energy being water in that bucket. Even if you have a very small hole, all of the water tends to escape from this envelope, and you need to invest on fixing those issues. It doesn't matter what thick wall of the bucket you have. The water, it tends to escape from the pad that it can escape from, and that's the holes. So the second issue that looking at different building components individually has is not yielding overall a strong performance in potential cases. And it's a case-by-case basis depending on what project you have. When we look at the Canadian data, we see that average house in Canada in a few years ago, based on the numbers that they have from a few years ago, is spending something more than 120 gigajoules of energy per year. And thinking about this, putting this into context, imagine when you make pasta, you put cold water on the stove, how much energy it would need to bring that cold water into boiling. Now, 120 gigajoules is enough to boil up a swimming pool. And that is for one average house for a single year in Canada. So the importance of moving to something better, I think, should make itself apparent. Okay, so let's say we take it in an individual level. We look at different individual pieces. So the Sahan's team, the architect, the energy advisor, they take note from these systems, and they start just putting those information down. And now it's time for Sahan to start calling different manufacturers. So he finds three companies for Windows, gets three companies for framing and installation, and multiple companies for other things, and it starts to make choices between these companies. So let's say for the Windows, he goes with company B, and when the all of the properties are the same, the aesthetics are the same. It all comes down to Sahan knowing that he has a high school classmate in that company who is a sales rep, and he just goes with that one. Goes to the framing and installation again, like looking at very similar codes and similar situations. He goes to company C because they have worked out in the last project, and that's a more than valid reason to use and someone for this project as well. And for other aspects of the project, he may continue working with people or work based on cost recommendation, his intuition of why why one product, one company would work better than the other one, or some arbitrary reason. And this brings us to the third problem, is that the building choices do not need to be scientific. Well, some of them need to be, but a lot of these choices in the builder is left alone to make one choice based on sometimes somewhat external factors that don't really have anything to do with the quality of construction. And last but not least, well, all of us have finite amount of time, so it's very possible that in this process of finding the right product, finding the right contractor, finding the right supplier, there are people missed from this process. And these are going to be lost opportunities that potentially could have provided a better quality of construction to the builder. So there we have four key pieces of the previous process that we feel was stagnating the construction progress, was creating a lot of friction in the design process, and were causing a lot of lost opportunity and lost potential for the work that is being done, even on the same budget. So now let's talk about the performance-based system, the new system that our province is going towards, Canada as a whole is going towards, and is becoming increasingly the norm for finding how the buildings should be built. As many of you know, and I would like to go over this, the BC government has has created this program called the BC Step Code, which is a program that will take us to the net zero ready level of construction by 2032. Now, when you look at the amount of heat that a net zero ready home loses, you will see that it's actually not so much, and it's enough for you to heat up that home with a hairdryer. Um, think about it. Think about what sort of a jump it is going to be for our industry to get to that level, and that's why you see a hairdryer here. So every once in a while, we will have a higher baseline level of construction and the improvement of that every once in a while. And we are going to see this going towards that level by 2032. So we have to start from now so that we are able to actually reach that level of that next generation of construction by then. Now, in the performance-based construction, we don't really think about the individual components. Thinking about the examples we provided, it only works out if we think about the building as a whole. So the construction team in this example, they will go through the whole system, look at the whole envelope, looking at what are the key pieces, the weakest paths of heat loss, and they will try to holistically make the system better. They will try to keep the heat or cool in and minimize the need for the active elements to be there, and definitely that will make such a home that needs way less than 120 gigajoules of energy every year. But this also creates a new challenge, because anything you change in this house is tied into all of the other options you have in the construction. So every change will have cascading effects over other changes. And this is not intuitive for the construction team to go forward. Talking about coming up with the best design, it seems almost impossible with the previous systems to go through this design process. So thinking about it, as we started to solve number two problem, which is that houses were not performing as intended, we have exacerbated the negligence for other problems that we had in the construction process. We cannot now omit the usage of energy efficiency early within the project. We cannot go with the gut feeling for finding the best construction choices. And we cannot also limit our scope in terms of what sort of building choices are available to us. Finding the performance issue requires all of these four problems to be solved at the same time. So that's what StepWin essentially does. We get all of the choices you have within a project that may confuse you, or may not give you that foundational design that you need, what you want to find based on your project. And as every project is different, as every project can have 54 million possible ways of construction, for that individual scenario that that project is in, based on climate and the shape of the building envelope and the building shape in general, this system becomes very, very complex. But the StepWin simplifies this process by a lot. We basically get all of the choices you have and the dimensions you have, the sort of building you're thinking about making. And again, the level of detail will be very, very low, and something that you can start using at the very early stage of the project. And a StepWin will give you the best cost and energy performance for that particular step. So it will give you a cherry picking of all of the options that work together integrally, and they are also not breaking the bank. And thinking about this system, it really works well when you have a starting point. So let's say Sahand is limiting his design process to finding his process constraints, to finding what sort of things is the most important for him. And he comes up with three window systems that he wants to explore more than everything else. One of them is very costly, but is also high performance. One of the other two are having somewhat comparable cost and somewhat comparable performance. And he, without a tool like StepWin, he may go with one of those. But as you look at this project in the whole arc of it, you will see that each of these systems, each of these starting points, send Sahand down to a completely different route. A route where each of these building choices may lead to other choices. And when you look at the overall performance of the building, you may actually see that that expensive window, although it seemed like a premium in the beginning, at the end of the project, when we look at everything overall, have been a cost saver, because you didn't need to go over other parts of the building and try to compensate for the shortcomings of it. Again, think about the example of the leaky bucket. And we essentially just spending our funds on addressing the leaks as opposed to going and doing other things. The other byproduct of this process is that now Sahand has very specific criteria for what he will need in the project. We just don't ask him to go for a high performance window. As you will see when Sahand is going over the StepWin reporting page, what we are telling the builders are very, very specific numbers. For example, it could be a U value of 1.2 and solar heat gain coefficient of 30.35. And that would mean that the manufacturers who are providing that flexibility in their options are going to be the best choices, because now we have a lot more capacity in order to meet the project's demands. So I want to leave you with these, with the conclusions of this, just bringing everything back together and tying it together, is that a successful construction team works on three major things. The first thing is that they start the energy efficiency conversation early. And you may get tired hearing this from us on and on, but the reality is that this conversation for many projects is not being started early. So start it early and know the level of detail necessary for that, and it's not a lot. The second thing is identifying the right project constraints, where the project can use some of these options in order to come up with a better design, and where it's very important for the design team to limit the options and start those limiting options as the starting part of the design process. And finally, the flexibility is a very key piece. We see that more and more we are in need of tailored and specific properties for different choices in the building. Now, if you are a stakeholder, such as a supplier or a manufacturer, you may have had scenarios that you have shielded the builder from too many choices by omitting some of the potential scenarios, just to not create that confusion. As we're moving towards these performance-based systems, there may be some possibilities that those omitted choices can actually help the project a lot. And this more tailored process of finding the right choices in the building can create a significant cost, time, and basically effort saving in the construction project. So think about going to a StepWin and starting to use a StepWin with these things in mind, that you are starting your process early. You have a general idea of what sort of the constraints you have in your project, and you also have an idea of the sort of choices you're comfortable working with. And having that system in place with the sort of energy costing optimization that we are trying to bring on table with in the cities that the stepping available is for you for free right now and beyond, we think that this is going to solve all of these problems and create an overall integral project. So without further ado, I want to pass it on to Sahand, our technical lead, for an overview of a StepWin and how you can get access to it and how we can use it. So take it from here, Sahand, please.
Hi guys, how are you? I'm Sahand and I'll be doing the StepWin website demo for you guys. Well, this is our introductory page, so an introductory video that our one has made, and we're going to go to the first step of this process. The first step is the climate page, which will be asking for your address. Here we have a dummy web address at Port Moody. We're offering services at Port Moody, New Westminster, Kelowna, Kamloops, and Penticton currently. So after this, you input your address, and we're going to go to the general page. On the general page, we're going to be asking for the general shape of the building. So for this case, we have a 2-story building, which has a hip roof and a cathedral roof, and we have basements for this building. But I mean, we could have any combination of these. You could have flat, hip, gable all together, or you could have crawl, slab on grade, or basements, all of it together. And depending on which one of these options you choose, we might ask you for different things. For example, since we're asking for cathedral, we're asking for house volume, and you're going to choose you can choose the correct whatever units you're comfortable with. For example, I'm choosing cubic feet here. Also, we'll be asking you for exposed floors and adjusted unheated spaces. And there is an information button here that you can click on, and will take you to the videos explaining exactly what these are. On the next stage, we're going to do our roof assembly design. So we're going to have interior and exterior installations for our cathedral roof. These are default assemblies, but we can add other assemblies as well. You can add your own custom assembly with your own R value, material cost, and labor cost. And so you just fill in this information, and our software will include that into your computation and optimize for the best cost and best value for this specific design you have. Since we have cathedral roof, we also have the option for skylights. So you can put the right correct direction for the skylights, the dimensions and the type of skylights they are. And we go for a thick roof, its dimensions again, and the assemblies, default assemblies we have, which are 12-inch and 18-inch blown-in insulation. But again, feel free to add your own specific insulation needs and your own costing and your all our values. And our staff will include that into our computation. Next page will be the general, will be our main floor and second floor as wall assemblies, basically, and your general shape of the building. So you'll be asking for our wall assemblies, and you can add your own, of course, different wall assemblies here. And you'll be inputting your area, our parameters, and the wall heights for first floor and second floor. And we'll be asking for our windows, all sort of openings. So windows, patio doors, entrance doors for first floor and second floor. And the next stage, we're going to go for our foundations under slab on grade installations. So we have options for no installations, full slab, under slab, and full above slab installations. And you can choose any other and add your own. We also ask for you to provide us the amount of concrete foundation walls under the soil, the area, and the amount above the soil, and also your pony wall area, if you have any. At the next stage, we are asking for your foundation wall, which is the concrete wall installations. So you can have installation either inside or outside the concrete wall. You can have variation of these. You can have no insulation in the outside, insulation inside, or any of these combinations would work for our software. And at the bottom, we're asking for the openings for the foundation. Here, we only have two windows, two openings. Next stage, we're going to be choosing different types of windows and frames. So I have double glazed PVC, double glazed wood, triple glazed PVC, and triple glazed wood. And we have different coatings for very high coatings and to very low solar heat gains. And these are selecting these will cause your software to be choosing all of these options into your consideration, and will take it into account for the best optimal solutions. For our next page, we're going to be choosing our mechanical systems. So we have our heat pumps, your domestic hot waters, and ventilations. If you don't have any, for example, HRV, you can choose no HRV option. Or if you don't have any hot heat pumps or air conditioner, you can, of course, choose no auxiliary system. But you have to be choosing one of these options. Otherwise, the software will not let you go through the next page. So I'm going to be choosing these options, for example. And the next phase, we're going to be doing the major of the work. We're going to be computing all of these, maybe 40,000 combinations. And the software is going to be going through optimizing for the best performance and the best price. So now our simulation is complete here. And software is going to rank it based on the best performance here. And so we're going to see it's rank it based on the best performance, its price, and its pricing. As you can see here, this has $186,000 total energy related cost. So these are only thermal material and thermal bridging material. So your frames will include, but maybe not all the elements. So keep that in mind. This is not a total cost, and we have the breakdown of the portions of this cost you're dividing to. And we're providing the most important factor here are your TEDs and MUEs values, and your TD% and ARS percent, and which indicates that this house is a very, very, very efficient house at step 5, basically. We have your heat losses here, and as you can see, in the springtime, you get a lot of sun in the house, and heats up the sun. It's usable, very high usable internal gain. But when it gets to warmer months, you don't really use that sun much, and in the winter times as well. And we also have the details of this wall. So we have a specific walls, and then we have all the guides linked here. So you can click on these and go to these links to see the exact details of how to construct these walls and their efficiencies. Also for cathedral roof, attics, and windows, basements, and here we have our cost breakdown, and which goes through exactly how these costs were calculated and if there is differences here, you make sure you add that to your own, and maybe you can create another walls assembly and use that, because again, costs will be different in each region. If you like this design, you can store it, and this will be saved into our memory, and you can later on review it in the comparison sheet. I'm going to go over a few other stuff here. So we can also sort by price. So you can this is the cheapest design we have here, for example, and we can look at the easiest constructability, and can step 3s or step 4s. And these are all other options. And if you like any of these, you can, of course, you can add them to be compared. You can share this design with your architect inner guide with just a click of a button here, and this will download the H2K file for you, which you can easily share, and we run to the HAL 2000 program. So that will be very handy for your HAL 2000 guide. And the next thing I wanted to cover was that we also provide your greenhouse gas emissions here. Let me see if we have it. Should any of these should have it. So we have the greenhouse gas emissions here. So this house has a good emissions here, very low emissions anyway. And next page, we have our comparison page. Basically, this builder has decided to remove a window and add a window here in the step 2, and save this to his sheets, and another time it changed something else, and again wrote its description and saved it for later on to be compared. And we saved all of this into comparison sheet that they can later on review. I think this concludes my demo of the website. I'm going to give this to Arman. Thank you.
Thank you so much for the comprehensive introduction. Okay, so San, we are still missing your video, but oh wait, there you are. Okay, okay. So thank you so much for the very good introduction. And now we are going to just start going over the questions, which I know you have many, as this was meant to be a teaser. Again, keep in mind that you can access a StepWin through the website, and there are so many helper videos along the way that can help you to go deeper into the specifics of these designs, these specifics of these options that we have, and you can pretty much build anything with it right now. So as long as you have a single family home, you should be fine. And if you have a multi-unit, please make sure to reach out to us. All right, at this point of the session, I want to make sure that we are actually covering the questions if there are any. So Kayla, do we have any questions coming in the chat?
Yes, we have 2 for you to start off with.
Perfect.
First, okay, perfect. So I'll be going over the first one, and I apologize if I butcher any names here. Original Dude Lebowski asked, when you add your own assemblies, such as a wall, using hempcrete, does that go into the database for other people to use as well?
Okay, that's a really good question. First of all, you can use hempcrete for sure. So all you need to do, let me share my screen. So if you see my screen, all you need to do is to go to our wall, the place that the wall is, click on add new, and you will get the name, the R value, and the cost that you have for the material and labor. One thing to keep in mind here is that the R values are effective. So keep in mind the hempcrete systems, however the bridging is happening in there, make sure to calculate those, especially along the joints and corners. If you feel like there are significant bridging happening there, or along the window seams, make sure to include them inside this piece. In terms of reusing one material for other people, this is definitely a feature that we would like to introduce in the future, that you can actually have your even products, if you are providing products, to have some sort of a repository where other people can come and pick one up. But right now, that's not a feature. I mean, if as you are seeing here, for a new material, we are not really asking for much. We are basically asking for 4 things, and name is not that important. It's just for the results to show. So as long as you give people basically 3 numbers, which is the R values, material, and labor costs, I think everyone can just replicate them without any problem. So I hope that answers the question, and please let us know if that doesn't. Yeah.
Perfect. Thanks, Armin. All right, moving on to the next question, which is Matthias Olmedo. How is the software integrated with HAL 2000? Does it produce an inner guide file?
Oh, that's a really good question. Thanks again for the great question. So one thing to keep in mind is that the sort of analysis we do is for the very earliest stage of the project. Now, this is the stage that you are exploring a ton of things, but you may come up with a design that's very, 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 very powerful for being a foundational design for the rest of the project. So then it comes down to the energy advisor to narrow down and go on the very specifics of your project and work with you towards just getting your design to the next level. And that is where a StepWin just hands off. There is also the energy advisor. Now, as we give you a very handy report list that Sahan went over, which has all of the information that you will need from a project, including even some of the guides that BC Housing and other stakeholders in the industry have provided, which we create for which we show you and take you to the exact page where different assemblies are featured with the information that you will need. Beyond this living report, we also give you the opportunity to export this design as a HOT 2000 file, as Sahan mentioned. Now, this HOT 2000 file is not meant to be a EnerGuide file, a full EnerGuide file that the energy advisors produce. This is meant to be a starting point for your design, which has all of the information you have put into a StepWin, including all of the windows, all of the wall sizes and whatnot. And then it's the so I put one here that you see different ceilings, different walls that we have basically exported from a StepWin to HOT 2000. But then at this point, your energy advisor has the better tooling and the better knowledge to take your project to the next level. And that's where we hand this to the energy advisors. So you can definitely make good use of this HOT 2000 exporting option, but keep in mind that we are not trying to replicate the work of different energy advisors and the work of different professionals in the project. I just want to add to that please, when you are signing up, we have a disclaimer and also the usage notes that it's very short. You can go over them maybe in less than a minute or two. So go over them and understand what the StepWin does and what it doesn't. So hopefully that answered the question.
All right, thanks, Armin. Moving on to the next one. And Lloyd asked, can it look at foundation wall interface or wall roof interface?
Oh, for sure, yeah. So moving to the foundation interface. So we look at different alignments of insulations. That's the only thing that's important for us. And I invite you to actually create an account with a StepWin and go to these pages yourself. But the important piece here is that the helper files show how we are collecting that information from you. So we ask you for the interior and exterior insulation separately, and we see how they overlap with each other, and we get an idea of how what are the air leakage paths from your building. And we have a video for that. We have an explainer video for that as well. But essentially, all it comes down to is you putting on where you want to put the insulation, put the window dimensions, which is width and height. And as Sahan mentioned, you can just click on the unit to change them to feet. And a slab in the same way, where do you want to put the slab insulation and what sort of slab areas we are talking about. For the roof, it's a very similar thing. What sort of insulation you want to put in the roof, what is your roof area and the slope, and what sort of skylights you want to put in. So these are the three things we need from you, basically. What sort of assembly, what is the area, what are the penetrations. And that should be more than enough information for us to start doing your energy modeling.
Perfect. Thank you. We have a follow-up question from in regards to the first question you answered. Matthias asks, following up on the effective R value comment, are you following a particular method to calculate the effective R values?
Okay, that's a really good question. Thank you. Yes, so we typically tend to stay true to what we see in different guides that is published by government or credible sources that are going to give you are going to give you and us information. For example, when you go to your reporting page here in how to in sorry here in the StepWin, we give you some sources for different assemblies that we have chosen. And in some of them, you have the Energy Step Code Builder Guide or R22 Plus Guide and whatnot. So I clicked on the R22 Plus Guide. It takes me to that guide and the specific page that they have this wall featured in. And there you can find a sheet the way they have calculated the R value for the assembly. And that's the one that we have used in our interface. Now, knowing full well that different penetrations, different project conditions may actually significantly change your effective R value, the way you are working with the air films inside and outside, all of those considerations may change the way that you may do the R value. Think of these numbers as the starting points. And whenever you hover over, for example, I go to the roof page right now and I hover over each of the wall assemblies, we show you what R value we have put as our assumption. And this is something that you may be able to reach with the level of installation and calculation method you have. If not, by all means, feel free to add your own system and deselect all of our systems, so you know that you are comparing the roof systems that you have in a fair way.
Perfect. Thank you. All right. Another question is from Meredith. Meredith asks, how quickly will you be adding climate data from other jurisdictions, say from Invermere? So Invermere is the eastern part of BC. It's closer to Alberta, on the border of Alberta.
Yes. Oh, that's such a good question. So we are working really, really hard to try to bring in new climate and energy efficiency and costing data from different parts of BC. One thing we do is reaching out to different municipalities and try to see how much interest we have with different stakeholders in the industry to make that growth. So we have been adding many cities from the start of the year, and we're hoping that we can keep the pace and move on to newer regions. If you would like to know when we have some news for you, please join our newsletter. And also, we are all reachable through Lambda Science, info at Lambda Science, and also all of the channels we have on LinkedIn and whatnot. So please feel free to, if you need just to talk with us about your project, or you want to see if we have an update for you, please feel free to reach out to us personally, and would be more than happy to answer anything we can help with.
And Meredith asked, could you repeat the list of what climate zones are already included?
Yes, for sure. So we are right now available for the City of Kelowna, City of Kamloops, City of Penticton, City of Port Moody, and City of New Westminster.
Thank you. And that's all the questions we have for now. Is there any other questions or follow-up questions anybody has or would like to add to the chat box?
Okay, so while we wait if there are any more questions coming in, I just want to say that we are always reachable through info@lambda.science. Our website is lambda.science, so you can get a lot of useful information from our blog, hopefully our LinkedIn page, and also on the stepwin.ca website, which is the StepWin's website. We will be really excited to work with you on any project that you may have. So if you want to just explore something or have a bit general question, please feel free to reach out to us at info@lambda.science. The other thing I want to highlight here while we have the time is that in response to COVID-19, as you all know, everyone is doing a lot more remote work. And we have created a platform called meet.lambda.science, which is a website for anyone who wants to have a public event. This is available for you for free to host a webinar, a session just like the session we are having right now. So this session is facilitated by meet.lambda.science. And if you want to have something like that, please feel free to reach out to us, and we will be happy to facilitate your session via this system. It's the smallest thing we can do with the pandemic that everyone is facing. Our mission as a social purpose organization is to keep the construction industry connected and bridge those data and communication gaps that we have been facing with. So it's the least we can do. And if you are interested for that, please again feel free to reach out with us. And with that, Kayla, do we have any more questions?
We do.
Awesome.
So another question from original dude Lebowski. You said the software gives you an estimate of GHG emissions. Will this software give you any more of an LCA, like embodied energy?
Oh, great question. At this point, our concern with that is that we don't have a comprehensive way that is industry-wide accepted for calculating that life cycle assessment. But this is one of the major features that we want to bring in terms of what sort of carbon emissions each building is providing. So the carbon emissions, as Sahan showed inside our StepWin interface right now, is actually focusing on operational carbons, which are the sort of GHGs you get with the sort of mechanical system you have, heat pumps and whatnot. And we very well know that operational GHG emissions, as we have put in there, is not the whole picture. We want to facilitate and encourage the use of low carbon materials. And the only limitation we have right now is not finding a comprehensive carbon accounting system that is accepted and acceptable to everybody. We know that there have been a lot of amazing developments in that regard. The calculation of that is not easy. Sometimes it really depends on how much the truck is traveling to the construction site. So if you have any ideas about how we should make an assessment of LCA, please let us know and expect to see it in one of our future newsletters that we have rolled it out.
Perfect. Thank you. Another one. Do you consider the overheating comfort implications of using high solar heat gain windows on southern and western elevations? This is a problem when there are high windows to wall ratios.
Oh, great questions today. Like, people are great. Let me tell you that one of the things that we needed to focus on was what is anticipated in the BCS step code. And unfortunately, BCS step code does not have considerations for overcooling, for overheating, which we think is something that can be definitely improved and should be improved as our province is going towards a much more warmer future. And the climate change is going to make us actually really rethink that cooling argument. Now, what step code does provide is a small relaxation for the mechanical energy usage intensity for whenever there is an air conditioning in the house, which is a small bump that actually we consider in our system. But the closest thing we provide to that is this graph we provide about the envelope heat loss, usable solar gains, and usable internal gains. Now, this is not really showing the amount of total solar heat gain that is coming in from the south and west windows. We definitely think that we, in the future, StepWin must give users an option to somewhat see that the risks and the factors of overheating and how to mitigate that problem. There's a lot of great work that can be done with different coatings, with different overhangs, and even like providing extra shadings for the windows. And just having those information for informational purposes to the user, we think is going to be very important. This is hopefully a feature that you will see in the future, that we can show you what is the level of overheating that you will see in a house, and maybe give you a warning about the potentials of that. We also hope that the PCS step code has some sort of a future consideration for things like that, and they also consider cooling as a part of this whole process.
To follow up to that question, they just said the high solar gain windows should not be used on window to wall ratios greater than 15%.
Yeah, I'm saying that Al has said it, so
Yeah, Al.
I'm pretty sure. For those of you who don't know, Al is the is one of the technical people at the Fenestration Canada. So yeah, listen to his advice.
Thanks, Al, for the inputs. And we got a nice comment from Anne Lloyd. They said it's awesome that StepWin is web-based and has a modern interface, much better than Hot 2000.
Well, we don't want to draw comparisons, but we definitely were hearing a lot of the pain points that people had when it came to energy efficiency and navigating the energy efficiency pieces. So we are really hoping this will become an added tool on top of the familiar interface that HOT 2000 provides, and really creates that early stage simplicity that all of us can benefit from. And hoping that this will actually be taken forward with the input and feedback from the community, just as it has been taken forward for the last 3 years of its development.
All right, looks good. That is all the questions we have for now. Do we want to wait a little bit more for any more questions, or?
I would say we can finish it and let people go about their business for now. But thank you so much, everyone, for joining in. We will try to make a recording of this session available to you as well if you want to pass it around or just want to cover different parts of it. Again, you can access the software through stepwin.ca. Just find the place that says I'm a new user or I'm an existing user, and it will let you in the software. One last announcement I'd like to make is that we are working on some multi-unit projects, and we are really hoping to have some test projects with some of the people out there who want to test things out with us. So if you have one of those projects, please also feel free to reach out to us. Thank you, Kayla. Thank you, Sahand. And thank all of you for joining in this session. We hope that you have enjoyed it. Stay tuned for our next webinar, which is going to be the next month, just a month from now. And we will be going even in more depth. So feel free to reach out to us in the meantime. And we are hoping that you stay safe out there and you enjoy the rest of your day. Goodbye.
Bye-bye.